Okay, let's try again. Why don't I see my stream? Yeah, before I change something in my display settings, it's throughout the GPU. So hopefully it is better now. Just a quick summary of what we are doing in general, because I get that question a lot. There's this website called BindyChaos.com. It's also a project, also a YouTube channel. It has a bunch of tools, mainly run biomedical engineering, biomedical data science, data processing. There will be some information there. There's a new logo here. We are on LinkedIn, YouTube, Twitter, GitHub, Patreon. If you want to support this project, you're more than welcome. Now we had this bunch of tools running before. The YouTube channel evidence that they were actually working. Now not all of them are working, and we will be trying to recover them, and we get ChatGPT to help us with that task. So you have tools like ECG, scrolling games, for you to learn how to label how ECG is being labeled. You have all sorts of other things, mainly around ECG, EEG. We also had this image compression tool, so that's the one we will be working on today. So we have this bunch of brain images. We'll take one of them, say this one. We already had ChatGPT generating this code for us, so it's using Wavelet Transform library, and what it does is generating these two images. One is the original one is reconstructed, and this second image meant to be wavelet transformed, but then we have this PSNR signal to noise ratio of 53 dB. So that's all nice and good. So we have this description in here. Now the main thing we want to make turn this into, so if we pop this straight into GPT, it's actually, well, before it did, never know if it's how repeatable things are, but it will it's actually suggesting a different library. No, sorry, it's the same library, Python wavelets library. So it's generating pretty much the same code. Must fetch an example somewhere. Yeah, slightly different, but parameters input. So we have those inputs here as well. Just pop it again into create a copy test. I'll just show us another plot. We did close the previous one, yes. Right, the input data. That's where our image file is at. Yeah, it had a similar error before. Line 308. might just go with a few, one or two extra prompts, and then we'll move into web applications. So we'll be using Flask. So it's also available for you to play around with.
And then 3 tuple arrays for the detail coefficients, horizontal, vertical, diagonal, for each level. You'll have to maintain this structure when you quantize them. Here's a revised version of the code snippet, which properly quantizes the coefficients while maintaining the required structure.
Yeah, the previous code was better. It had all this more functions in it. This one just has the one. Did we rewrite the whole thing? Yes. So I have a data folder. Just want to sort out my folders on the get-go. This thing could be just data, I think. And let's pop this in. Yes, we have modified version of the code. Image path. Let's run this. Yeah, we were able to fix that thing before. I don't know what happened. Still the line 30.
The error message suggests that the original underscore image being passed to PYWT, wavedeck2, is not a 2D array, which is required for 2D wavelet decomposition. This could be due to various reasons. The image path might be incorrect, resulting in CV2, imred, returning none. There might be an issue with the OpenCV installation. You can check whether the image has...
Right, it's actually the data path, and I'm never too sure. No, one dot. Okay, I'll just go for the whole file. Sorry, it's always messing around with data folders and stuff. Copy path. Right, that's the whole path. The previous example had only 50 dB. Yeah, it's reconstructing pretty well. Why is this number so large? The PSNR. But it looks like exactly the same image. Okay, let's close this for a sec. So the thing is working now. So I would like to turn this into a web application using Flask.
Turning your image compression algorithm into a web application can be a great way to make it more accessible and user-friendly. There are several frameworks and libraries that can help you achieve this. Below are some approaches you could take. You can build a simple web application using Flask that will allow the user to upload an image and then perform the DWT compression and reconstruction. This is a good choice if you've written your compression code in Python. Here is a skeleton example to get you started. Install the necessary packages, copy code to pip install Flask open CV Python PyWavelets. Create a new file, app.py. If you're comfortable with JavaScript, you could also build a more interactive front end using a framework like React or Angular. The front end could allow users to select the wavelet type, number of levels, and quantization bits. The backend could be a Flask or Django API that processes the images. If you're looking for higher performance, you could compile your Python code to WebAssembly using tools like Pyodide. This would allow the code to run in the browser, providing a more responsive user experience. Add input forms or sliders for parameters like wavelet type, number of levels, and quantization bits. Add image visualization for original and reconstructed images. Implement metrics like PSNR as part of the result display. By turning your project into a web application, you can make it much more interactive and user-friendly.
Okay, so we had a standard structure that we used elsewhere as well. Saying this inverse noise. Oh, inverse noise, yes. So in here we'll have an up y. This is just a template. New JavaScript. We have prompts. It's for deployment. This is for prompts for another application. Don't worry about it. Just tell it to continue.
Certainly, continuing from where I left off. User authentication. Implement a login system if you want to track user data or restrict access. Asynchronous processing. For more complex operations that might take time, you could consider making the compression and decompression processes asynchronous. This will improve the user experience by keeping the UI responsive. Multiple file support. Implement functionality to allow users to upload multiple images at once, possibly in a zip file, and then perform batch processing. Visualizations. You could include a visual representation of the wavelets used in the compression or show side-by-side comparisons between the original and reconstructed images. Advanced metrics. Apart from PSNR, you can offer additional image quality metrics like SSIM, Structural Similarity Index. Download option. After processing, provide an option to download the compressed and/or reconstructed images. Progress bar. Add a progress indicator for the user to know the status of the compression and reconstruction process. Error handling. Implement comprehensive error handling to catch and display meaningful messages for any issues that could arise, such as invalid file types, errors in compression, etc. Logs and metrics. Maintain logs to monitor usage, errors, and performance metrics for future analysis and improvements. Documentation and user guide. A short guide or tooltips to help users understand how to use the application and what each parameter does can enhance usability. Front-end. HTML, CSS, JavaScript, and frameworks like React or Angular for more dynamic functionalities. Backend. Flask or Django for Python-based backend. You can use FastAPI for better performance. Database. Optional, only if you need to store user data. You can use SQLite for lightweight applications or PostgreSQL for more robust needs. Deployment. Services like AWS, Heroku, or DigitalOcean can host both front-end and back-end. By adding these features and considering these technologies, you can build a robust and user-friendly web application for image compression using DWT.
Right, that's great, but JavaScript? No. It was the other tool that we made a couple days ago. Yeah, the EG generator. Generate HTML.
Certainly, here's a simple HTML template that includes a form for uploading an image and selecting various parameters like wavelet type, number of levels, and quantization bits. It also includes a section to display the original and reconstructed images, as well as loss metrics.
And now, yeah, we also need the file and folder structure. It's HTML.
You can hook up this HTML with your Flask backend or any other server-side technology you are using. You can also enhance this with client-side JavaScript to allow for dynamic updates without requiring a page reload. Remember to update the action attribute of the form tag to match the URL of the server-side endpoint that will handle the form submission.
Right, so we can run this one in a live server. Yes, we get this essentially a form. Choosing a file. That's great. Upload and compress. You need some default values. They have to be populated. And let's see. And that's okay. Generate JavaScript.
Certainly. Below is an example JavaScript code snippet that uses the Fetch API to send the form data to a Flask backend and update the page with the results. This code assumes that the backend returns a JSON object containing URLs for the original and reconstructed images and a value for loss measurement. First, let's update your HTML form with an id so we can easily reference it in JavaScript. Here is the JavaScript code to attach to your HTML page. In this example, once the form is submitted, the default form submission is prevented using event, prevent default. The form data is captured and sent as a post request to the compress endpoint on the server. The server processes the image and returns a JSON object containing the URLs for the original and reconstructed images and the loss measurement. The DOM is updated with the new images and loss measurement. Note that the actual server-side endpoint URL and the JSON keys, original_image_URL, reconstructed_image_URL, loss_measurement, need to match what your server is actually using. Also, the server should handle the uploaded image and parameters appropriately for this to work.
Okay, that gets a bit complicated, but we can manage, can we? Can we generate the file and folder structure for the project?
Certainly, below is a sample file and folder structure for a web-based project that does image compression using Discrete Wavelet Transform, DWT. Here's a brief explanation of each file. Backend/app.py, the main Flask application file where you define your routes and handle incoming HTTP requests. You will receive the uploaded images and parameters here, then perform the DWT and send back the results. Backend/requirements.txt, a list of Python packages that your project depends on. You might include packages like Flask, NumPy, and PyWavelets here. Backend/utils/dwt.py, functions related to DWT, Discrete Wavelet Transform, and IDWT, Inverse Discrete Wavelet Transform. Backend/utils/metrics.py, functions to compute metrics like PSNR, peak signal to noise ratio. Frontend/css/styles.css, any custom CSS styles for your web application. Frontend/js/script.js, JavaScript code to interact with the HTML form, send requests to the server, and update the DOM. Frontend/index.html, the main HTML file containing the UI for your application. Users will interact with this page to upload images and get compressed results. Images, processed, a folder to store the processed, compressed, and reconstructed images. README.md, documentation for your project, explaining how to run the code, the folder structure, and any other important information. Gitignore, a file specifying patterns of files that should be ignored by Git. For example, you might ignore the images, processed, folder, and any .md files containing environment variables. This structure separates front-end and back-end code, making it easier to manage the application. You can, of course, modify this to better fit your specific needs or technologies you're using.
Yeah, let's follow this structure. We'll rename data into images. Generate the README file for now.
Certainly. Below is a sample readme.md file for the DWT image compression project based on the folder and file structure provided earlier. This project provides a web-based application for image compression using Discrete Wavelet Transform, DWT. Users can upload images and select various parameters like wavelet type, number of levels, and quantization bits for compression. The original and reconstructed images, as well as loss metrics, are displayed as output. Python 3, X.
Now that's okay. So the same structure. Yes. So we have backend, we have the Python Flask application, the backend folder. Just generate the requirements. Then we have folder of utilities. So no but this file what else do we have? We have front end. Normally we'll need the folder called static. Do I need a folder called static?
The term folder called static is not commonly used in software development or programming.
Have the requirements file.
In a Flask web application, the static folder is typically used to serve static files like CSS, JavaScript, and image files. Given your project requirements, especially since you're dealing with images, original and reconstructed, it would be good to have a static folder. Here's how you could update the folder structure to include it. If you choose to serve the front end using Flask, instead of as standalone HTML, CSS, JS files, you would typically put your index, HTML inside a folder named templates, and your static files, CSS, JS, images, etc., inside a folder named static. In Flask, you can then refer to these static files in your HTML templates like. Certainly, below is a simplified Python code sample for a DWT.py file that you could include in the utils folder of your backend. This script uses the PyWavelets library to perform Discrete Wavelet Transform, DWT, and Inverse Discrete Wavelet Transform, IDWT, for image compression and reconstruction. Note: make sure you've installed the required packages specified in the requirements.txt file.
Those just commented out.
This is just a starting point, and the actual implementation might vary based on specific requirements. Here, I've implemented three main functionalities. DWT_2D takes an image, wavelet type, and number of levels as input and returns the DWT coefficients. IDWT_2D takes DWT coefficients and wavelet type as input and returns the reconstructed image. Quantize takes DWT coefficients and the number of bits for quantization, then returns quantized coefficients.
Right, so we changed the file folder structure. Probably don't need the back and front end folders. Do I need the back end and front end folders? Probably not.
The need for separating the project into backend and front-end folders largely depends on how you plan to architect your application. Scalability. If you expect your application to grow in complexity or features, a separation between front-end and back-end can make the codebase easier to manage. Development speed. Front-end and back-end can be developed in parallel once the API contract is established. Reusable back-end. The back-end can be consumed by different front-ends, web, mobile apps, other services. Technology independence. You can swap out either layer with minimum impact on the other. For instance, you could replace the front-end technology stack without affecting the back-end logic. Simplicity. If the application is simple and doesn't require a lot of interaction between front-end and back-end, keeping everything in a single folder might be easier to manage. Quick prototyping. Faster to get up and running since you don't have to worry about setting up communication between two separate layers. If your focus is on building a small to medium-sized project and you're not planning to separate the front-end and back-end development among different developers or teams, you can keep them in the same project. If you're looking at a larger, more
Yeah, let's rewrite this into a single project. Just make it.
Certainly, you can keep both the front-end and back-end code in the same project for simplicity. In this case, the folder structure would look somewhat similar but without the explicit back-end and front-end folders. Here's how you might organize it.
Also want to...
In this setup, app.py would handle both the back-end logic, e.g., image processing, and serving the front-end, e.g., HTML templates and static files. This is a more consolidated approach and could be quicker for prototyping or smaller projects.
Can I remove CSS? Folders.
Certainly, if you're not using any custom CSS or JavaScript files, you can simplify the folder structure by removing those folders.
Keep files. What's the stop generating button? It's gone. Why the images are processed images? Okay, this is better. So I want a folder called Other. For testing, whatever. Yeah, that's the legacy. Rename it into old, put it in Other. Close all for a sec. Save. Save. Info. Right, so that's the folder structure that we have. Images can be placed into static folder. Have styles and JSON. JavaScript unit as well. Utilities, just in the main folder. Up, the Flask application, main folder. Requirements, main folder. So we don't need the backend folder. We don't need the front end folder. Right, so we have app requirements, and we have utilities. Can we generate matrix by, or at least the template for it?
The metrics.py file could include various image quality metrics like peak signal to noise ratio, PSNR, mean squared error, MSE, etc. Here is a basic example of what the metrics.py file could look like. This example includes a function for calculating PSNR. MSE, function to compute the mean squared error between the original and compressed images. PSNR, function to compute the peak signal to noise ratio based on the MSE.
MSE meant to be mean square error. PSNR, peak signal to noise ratio, essentially tells you how the reconstructed image. So we have it in here, for example. That won't work. That. Okay, these two Python scripts don't work. It's okay, we don't really need them because we're now relying on this file. So the HTML currently we should rewrite this. Wait, this styles. Script. Did we have it already? Probably not. Did we delete it by mistake?
The script, JS file will handle the client-side logic of your application. Depending on how you set up your backend, this could include sending requests to process images, update the UI based on user selections, and display the processed images and metrics. Here's a basic example. In this example, handle submit function is triggered when the form with the image form is submitted. It sends a post request to process image on the server, passing along the form data which includes the image and any selected options, e.g., type of wavelet, levels, etc. Upon receiving the response, it updates the UI by setting the source of two image elements, #original_image and #compressed_image, and displaying the PSNR and MSE values. Note, this is a simplified example. In your actual application, you might have additional logic and error handling. Also, the server-side root process image should be set up to receive this post request, process the image, and return the necessary data.
We have the images, we have the JavaScript styles, CSS. No, we don't.
The styles.css file will contain the CSS rules to style your web application. Depending on the layout and components you have in your HTML, you could add different styles. Here's a basic example to give you an idea.
We have this colors. We have our own color scheme now.
In this example, basic styles are applied for body, headings, and paragraphs to remove any default margin and padding. The body is given a background color and some padding. Form and button styles are defined to improve their appearance. Images, hashtag original image and hashtag compressed image, are styled to have some margin and a max width. A metrics class is defined to style any quality metrics displayed on the page.
Oops. Use. We want this colors. Should just rewrite the CSS.
Certainly, you can use these color theme swatches in your styles.css file to make the design more consistent. Here's an updated version of the styles.css incorporating your color themes.
It's a background, black background. We can keep it as that for now.
In this updated style sheet, the color theme swatches are defined as CSS variables under the root pseudo class, which allows you to easily change the colors across the entire style sheet by editing a single line. These color variables are then used to style various elements like the body, headers, form, buttons, images, and metrics display.
Pretty sure we had the README already, but okay, hopefully. So we're already 40 minutes into this. And we haven't even started
Creating a
developing.
readme.md file is essential for any project, as it helps others understand the purpose, functionality, and setup steps for your application. Below is a sample readme.md for your image compression with Discrete Wavelet Transform project. This project provides a web-based application to compress images using various types of discrete wavelet transforms, DWT. Users can select different wavelet types, compression levels, PSNR, dB, and bit levels to optimize the compression according to their requirements. Image selection. Upload images for compression. Wavelet selection. Choose from different wavelet types such as HAR, cowavelet, orthogonal, etc. Levels and bits. Select the number of levels and bits for compression. Metrics. Evaluate the quality of compressed images using PSNR. Output. Display the original and compressed images along with loss metrics. Python 3, X. Pi wavelets. NumPy. Pillow. Certainly. Here's a basic index HTML template that you can use as the starting point for your web application for image compression using Discrete Wavelet Transform.
So I forgot
In this
my
index,
microphone.
HTML. The form, image form, allows users to upload an image file, select the wavelet type, number of levels, PSNR, and bits. Two image tags, original image and compressed image, are provided to display the original and compressed images. A div with the class metrics is included to display the PSNR value and loss after compression. Feel free to adjust this template to better suit your specific project requirements.
Something not right. Is it loading CSS? No. What? What's the MIME type? Is it a common? Assume that's a common thing.
The error message indicates that the browser refused to apply the style sheet because the MIME type was not what it expected for a CSS file. This is commonly caused by incorrect path references or server configuration issues. Here are some possible solutions. Ensure that the styles.css file is correctly referenced in your HTML file. The issue may be that the browser can't find the styles.css file because the path is incorrect. Since you're using Flask, the styles.css file should typically be located in the static folder, and you should reference it using Flask's URL_for function in your HTML, like so. If you are using Flask, make sure the server is correctly serving the static files. Your app.py should contain something similar to this. If you've restructured your project, ensure that Flask is still able to correctly identify the static directory. Sometimes the browser caches older versions of files. Try clearing your browser cache and then reloading the page to see if the problem persists.
And still can't find the CSS. Yeah, it sounds like we're not gonna start developing today, but yeah, we got the project structure and everything. That's what it meant to look like, roughly, very roughly. And can't find the file. So CSS. And view. Sorry, I was playing around with this before and I stuffed things up. Just go to no breadcrumbs. Do we need breadcrumbs? Okay. So the style is in the static folder. And so why we are not able to find it? Text HTML. Searching image compress wavelet templates. No. What's all that stuff? Adding all this fluff to it, to the URL.
The issue here is that the URL_for static file name equals styles.css. Flask template expression is not being evaluated and appears directly in the URL, which suggests
Right.
that Flask's Jinja templating is not processing this HTML file. Here are a few things you can check.
Right, so we're actually not doing this correctly. We have to run this Python script, the Flask application, and run it through here. Don't see. Okay, so this is working okay-ish. It's one, that's the icon error. Don't know why. So we don't want to choose files from instead of selecting a file from a folder, we want to be able to select one of the image files from the static/images folder.
To select an image from the static images folder, you can populate a drop-down list with the names of the image files available in that folder. Then, you can use JavaScript to update the image displayed based on the user selection. Here's an updated index, HTML that includes a drop-down to select an image. Here's an updated script, JS, that populates the drop-down with image file names from the static images folder and updates the displayed image based on the selected option. Lastly, you would need to add an endpoint in your Flask app.py to serve the list of image file names. Now, when the page loads, it will populate the dropdown with the names of all image files in the static images folder. When the user selects an image from the dropdown, the original image will be displayed.
And we also make sure that other inputs are visible on the screen straight away. Also, make sure that default options are available and selected so that when page loads, it displays both original and wavelet transformed image.
To make sure that other inputs are visible on the screen and that default options are available and selected, you'll need to make some changes to the HTML, JavaScript, and Python files. Here's how you can do it.
I did remove one option at hardcore flat and bi-orthogonal. Removed one of them.
Now, the page will populate the dropdown with the names of all image files in the static images folder. When the user selects an image from the dropdown, the original image will be displayed. The first image in the static images folder will be set as the default image and will be displayed when the page loads. You'll also see a placeholder for wavelet transformed images, which you can replace with actual processed image paths. You can add more input fields in the HTML as needed, such as levels and wavelet types, to fit your requirements.
And this prompt here that we could use. So I'm having trouble integrating.
Certainly. Here's the complete index, HTML code with all the necessary elements for image selection, wavelet type, levels, and bit selection. I've also made sure to include default options for each drop-down menu.
Right, now it's back the 3 wavelets. So how's the default values being selected?
This HTML template includes drop-downs for image, wavelet type, levels, and bits. These will be populated and managed by the JavaScript code in script.js. It also includes display areas for both the original and reconstructed images.
Style should be okay. We need the JavaScript. To understand how the Python thing is linked to it. Copy this for a sec. Generate the whole updated code without missing bits or placeholders. Keep all unchanged code. Include change code. Yes, we have that. And we need the JavaScript.
Certainly, here's the updated script.js file. This assumes that you have a static images folder on your server where the image files are stored. I've included code to automatically populate the image selection dropdown with files from that folder and set default options. This JavaScript code does the following. Upon loading the DOM, it populates the image select dropdown with image file names retrieved from the list_images endpoint. Sets the default image to the first image in the image select dropdown. Updates the images displayed on the page based on the selected options. You'll need to implement the list_images and compress endpoints on your server. The list_images endpoint should return a JSON array of image file names in the static images folder. The compress endpoint should take the image, wavelet type, levels, and bits as query parameters, perform the DWT compression, and return the compressed image as a blob. This script.js should reside in your static directory. Make sure the paths in your app.py or backend server code align with what's specified here.
Check the folders. It's the images. No, that's the function. static images. Yeah, that's correct. Image. I think it's just, yeah, we'll select the first image in the folder as default. That should be fine. We need to regenerate the app, the Flask application.
Certainly. Below is a complete example of app.py that should work with the index, HTML and script, JS files previously provided. This example assumes that you are using Flask for your backend. Note that this example contains placeholders for the actual image compression logic, which should be implemented in your DWT.py and metrics.py. In this example, the root serves the index, HTML file. The list_images root returns a list of image file names stored in a static images directory. You can replace the image_files list with code that reads the file names from the static images directory. The compress root takes image parameters, runs the compression. This is where you would implement your discrete wavelet transform and other logic, and then sends the compressed image back to the client. You'll need to implement the actual image compression logic where indicated, probably using functions from your DWT.py and metrics.py modules. Make sure you place this app.py in your backend directory as per the folder structure you've outlined.
Don't have a backend directory, so a couple things. First, I forgot about these two files, now 2 Python files. Second, those images. Can you just retrieve the image files from the image folder in the static folder?
Certainly, you can retrieve the image file names programmatically from the static images folder. Here's the updated section of the app.py file.
Okay.
In this updated version, the list_images root uses Python's OS library to list all the files in the static images directory. It returns this list as a JSON array. Make sure the path static images correctly points to where you are storing the images in your project structure.
Right, so that's Python script. Right. This is great. As in, it's not doing anything because getting a JSON. So the compressed image is not there. It's getting excited too early. Too early. So I have this tool. And generate. I think we already had it before, but I'll stop this. Okay, and we haven't even started development yet.
Certainly, I can provide a skeleton for your DWT.py and metrics.py files. These files should be placed in the utils folder as indicated in your project structure. This file will contain functions related to Discrete Wavelet Transform, DWT, and Inverse Discrete Wavelet Transform, IDWT. This file will contain functions for calculating metrics like PSNR.
Right, so what's this file
In
doing?
DWT.py, the DWT_image function takes an image path, wavelet type, and the number of levels for the DWT. It returns the DWT coefficients. The IDWT_image function takes these coefficients and the wavelet type and returns the reconstructed image. In metrics.py, the PSNR function calculates the peak signal-to-noise ratio between the original and compressed images, given their paths. Remember to add additional logic for your specific needs, such as quantization and other types of compression in DWT.py, or additional metrics in metrics.py.
Can you do it for me?
Certainly. Below is an extended example with added features like quantization in DWT.py and an additional metric, the mean squared error, MSE, in metrics.py. Added a quantization function and integrated it into the DWT_image function. Added a function to compute the mean squared error, MSE.
By the way, the original images are very small already. So probably already compressed, but we can just play around with them, see what we can get.
In the updated DWT.py, the quantize function quantizes the wavelet coefficients. This quantization step is integrated into the DWT_image function, which now also accepts the number of bits for quantization as an argument. In the updated metrics.py, a new function MSE computes the mean squared error between the original and compressed images. This function is also used within the PSNR function for better modularization.
Right, so we have DWT. Should definitely be better than what we had before. And the Python application, the Flask application is already restarting. We have this metrics as well. Let's restart this. Getting in. Let's try to write to compress the image, but we don't have it. Why?
The 500 internal server error suggests that something has gone wrong on the server side. Debugging this issue typically involves examining the server-side logs for Python stack traces or error messages. Check server logs. The Flask server console should show an error traceback. This will help you pinpoint the part of the code causing the error. Invalid path or file. Ensure that the file, MRI brain with contrast 0002.jpg, exists in the expected location. Dependencies. Ensure all server-side dependencies are installed correctly, as specified in your requirements.txt. Parameter issues. Double-check the parameters you are passing in the GET request, including the wavelet type, levels, and bits. Code issues in DWT.py or metrics.py. If you've made changes to these files, make sure those changes are not causing the error. Check for common problems like type mismatches, null pointers, or unavailable variables. Without specific code or error tracebacks, it's challenging to diagnose the problem accurately. To resolve this, you can isolate smaller parts of your code and test them individually to identify where the error occurs.
So it's searching for compress image. Do I need that folder? So writing into compress. No, I don't have it. Are we trying to write into folder called compress? If so, I don't see it in on my server.
The 500 internal server error message suggests a server-side issue. The URL endpoint compress image equals MRI brain with contrast 0005.jpg and wavelet equals cowavelet and levels equals 4 and bits equals 8 seems to indicate that you are trying to call a compress function on the server side when this URL is accessed. The compress endpoint is likely defined in your app.py file, and it probably handles the compression logic. The query parameters, image, wavelet, levels, bits, are likely passed to some server-side function for processing. Here are some things to check. Function definition. Make sure that your app.py defines a root for compress and that this function is working as expected. Error message. Look at the server-side console or logs to find the specific error message and traceback. This will help you understand what exactly is going wrong. File and folder access. The server might be trying to read a file or write into a folder that does not exist or is not accessible. Double-check your code to see if you are specifying paths correctly. File existence. Ensure the image MRI brain with contrast 0005.jpg exists and is in the correct location, accessible by the server. Wavelet type. The query parameter specifies wavelet equals cowavelet. Make sure this is a valid wavelet type that your code can handle. You mentioned a folder called compress. Normally, you shouldn't need to have a folder named compress unless your code specifically.
That's okay. It's I know what the problem is. There's no code there.
Certainly. Below is a template for your app.py file in a Flask web application to handle image compression using Discrete Wavelet Transform, DWT. This assumes that you have utility functions for DWT and metrics, like PSNR, in DWT.py and metrics.py under the utils folder. Make sure you've implemented compress_image, decompress_image, and calculate_PSNR in your DWT.py and metrics.py under utils. Remember to create the index, HTML and JavaScript files, script, JS, to interact with these endpoints. Please adjust this sample code according to your actual code and requirements. Also, ensure you have a requirements.txt with all the necessary packages, like Flask and PyWavelets, so they can be installed with pip install requirements.txt.
There are more issues now.
The error message indicates that Python is unable to import the compress_image function from utils.dwt. Here are some potential reasons. The function doesn't exist. Double check that the compress_image function actually exists in your dwt.py file under the utils folder. Typographical error. Ensure that the function name in the dwt.py file is spelled correctly and matches with what you're trying to import. Python path issue. Make sure that you are running the script from the appropriate directory where Python can locate utils.dwt. Circular import. Ensure that you are not running into a circular import problem. That is, make sure that dwt.py doesn't import from app.py directly or indirectly. Syntax error in dwt.py. If there's a syntax error in dwt.py, Python won't be able to import from it. Check to make sure the syntax is correct. Here's a skeleton of how dwt.py might look like. Please ensure that the function names and parameters align with what you're trying to import in app.py. Certainly. Below is a template for DWT.py which contains functions for image compression and decompression using Discrete Wavelet Transform, DWT. Please note that this is just a sample structure. You'll need to fill in the logic based on your specific requirements. In this template, compress_image is designed to perform the discrete wavelet transform, DWT, on an image and then quantize the coefficients. Likewise, decompress_image performs the inverse process. You should add your own logic in the quantize and dequantize functions, as well as any other specific behavior you need for your application. After you complete the file, make sure to place it in the utils folder so it can be imported correctly into app.py. In this template, compress_image is designed to perform the discrete wavelet transform, DWT, on an image and then quantize the coefficients. Likewise, decompress_image performs the inverse process. You should add your own logic in the quantize and dequantize functions, as well as any other specific behavior you need for your application. Certainly. Below is an updated version of DWT.py, which includes sample logic for the quantize and dequantize functions. Here, quantization is simulated by rounding the wavelet coefficients to a limited number of decimal places, determined by the bits parameter. Dequantization is simply the inverse of this operation. Again, this is a simple example to give you a basic idea. The quantization and dequantization steps are essential parts of any compression algorithm, and they can be much more complicated depending on your requirements. After you complete this file, place it in the utils folder so it can be imported correctly into app.py.
It's just changing the names of the functions. I don't know why. Probably could have combined this two.
Certainly. Below is a sample metrics.py file, which includes a function to calculate the peak signal to noise ratio, PSNR, between the original and reconstructed images. This can serve as a quality metric for the image compression you've implemented. Place this metrics.py file in your utils folder so it can be properly imported into app.py or any other part of your application where you need to compute these metrics.
Oh, come on, the select image. It's not populated. The select image is not populated.
If the image selection dropdown is not populated, it might mean that the script you are using to list image files from the static images directory is not working correctly. Here's how you can populate the image selection dropdown dynamically using Python, Flask, and JavaScript. app.py. Include an endpoint to send the list of image file names to the front end. Script, JS. Fetch the list of image file names when the page loads and populate the dropdown. Index, HTML. Include an empty dropdown that will be populated by JavaScript. Make sure you have a folder named static images where your image files are located. This way, when the Flask app runs, it will populate the dropdown with the file names in that folder.
I already had this functionality. Why did you remove it? Right, well, we reached giving us a timeout. After 7:20, it's like 6:30. It's almost an hour. It's actually interesting that it continued the same conversation when I dropped down to GPT 3.5.
I apologize for any confusion. It appears there might have been a misunderstanding in your previous messages. If you already had the functionality to populate the image selection dropdown, there was no need to remove it. To clarify, you can keep the existing functionality for populating the image selection dropdown as you had it before. If you need assistance with any specific issues related to that functionality, or if there are other aspects of your project that you'd like help with, please feel free to provide more details and I'll be happy to assist you further.
Can you generate a summary of the current project?
Certainly. Based on the information provided, here's a summary of your current project. Project name, image compression using Discrete Wavelet Transform, DWT. Project overview. The project aims to perform image compression using the Discrete Wavelet Transform, DWT, technique. It allows users to select an image, choose DWT parameters, wavelet type, levels, and bits, and then compress and evaluate the quality of the compressed image. It provides endpoints for displaying the main web page for user interaction, handling image compression requests based on user-selected parameters, dynamically listing image file names from a folder. The backend uses Python libraries such as Flask, PyWavelets, and OpenCV for image processing. Frontend, HTML, JavaScript. JavaScript, script, JS, is used to dynamically populate the image selection dropdown and interact with the backend through AJAX requests. The DWT.py module contains functions for image compression and decompression using DWT. The module includes placeholders for quantization and dequantization logic. Quality metrics, utils/metrics.py. The metrics.py module calculates quality metrics, such as peak signal-to-noise ratio, PSNR, between the original and reconstructed images. It provides a placeholder for PSNR calculation. The project has a specific folder structure, including static for static files, utils for utility modules, templates for HTML templates, and the main app.py file for the Flask application. You have mentioned some to-do items in your project plan, such as adding a PSNR versus bits versus wavelet versus levels chart and providing the actual wavelet type in the wavelet selector. Overall, the project allows users to experiment with image compression using DWT and evaluate the trade-offs between compression parameters and image quality. Further improvements can enhance its functionality and usability.
And once we are not timed out anymore by how do we, let's assume starting a new chat. How do I go back using GPT-4?
To navigate backward in the conversation using GPT-4, you can simply describe what you want to return to or ask a question related to a previous topic. Here's how you can do it. Refer to a previous topic. You can say something like, let's go back to discussing the image compression project, and then provide your question or request related to that topic. Request a recap. If you want a summary or recap of the conversation up to a certain point, you can ask, can you summarize what we've discussed so far? Specify the context. You can provide context for what you want to return to. For example, regarding the DWT image compression, can you explain how to calculate PSNR? GPT-4 should be able to understand your request and provide responses related to the previous topic or context you mention. If you have a specific topic or point you'd like to revisit, feel free to mention it, and I'll assist you accordingly.
That's not what I was asking. You gave me a timeout for using GPT-4 and reverted using 3.5. After the time have lapsed, how do I go back using GPT-4?
I understand your question now.
It's much quicker.
If you were temporarily switched to GPT 3.5 due to a timeout while using GPT-4 and you want to return to GPT-4 after the timeout period has passed, you can simply continue using GPT-4 in your conversations. There's no specific action required on your part to switch back to GPT-4 once the timeout has ended. Here's what you can do. Wait for the timeout period to expire. When you start a new conversation or continue an existing one, you will automatically be using GPT-4 again. You can interact with GPT-4 as you normally would, and it will provide responses based on its capabilities and the context of the conversation. There's no manual switching process involved. It will automatically resume using GPT-4 when the timeout period is over.
Okay, might take a break then. Be back in a sec. Yeah, just continue for a bit. let's see what we've done so far. Yeah, we had that thing. Let's see where thing got stuffed up. Oh, yes.
Certainly, I'll provide a version of the app.py code with all the existing logic intact and without removing any placeholders. Here's the regenerated code. This code retains all the existing logic and placeholders. You can continue to add your custom logic and complete the placeholders for compression, decompression, and quality metrics as needed for your specific project. Certainly, here's the updated app.py code with the requested modifications. This code retains all your existing logic and placeholders as requested. It includes all the unchanged code and does not remove any existing logic. If the select image dropdown is not populated with image options, it might be due to an issue with fetching the image names from your server. You can modify the JavaScript code in script.js to dynamically populate the dropdown when the page loads. Here's the updated code for script.js. In this code, the populate image dropdown function fetches the list of image names from the server and populates the dropdown with the available options when the page loads. Additionally, the update image function updates the displayed image when a new one is selected from the dropdown. Certainly, here is the updated app.py file for your image compression web application. This code defines the list_images endpoint to retrieve the list of available image files in the static images directory and the compress endpoint to handle image compression requests. Make sure this app.py file is placed in the root directory of your project. I will provide you with an updated app.py that includes the logic for populating the image list and updating the dropdown in response to user requests. Ensure you have the necessary packages installed, including Flask, and make sure your project structure is set up correctly. In this updated code, the list_images endpoint fetches the list of image names from the static images folder and returns it as a JSON response. The root retrieves this list and passes it to the index.html template for rendering the dropdown. Please make sure to place this code in your app.py file and update your index.html template to use the image_files variable to populate the dropdown.